really stretched out my tongue. I wonder how far I can get it to stretch.
Whoa there, that sounds kind of dangerous. Why don't we test this out in a way that's a little more safe?
All right. How would we do that?
We need the right materials. We could get them from the...
That was oddly convenient.
Yeah. Well, we'll use a spring, kind of like your tongue, and the weights will be like the rocks. As we add more weight, we'll measure how much the spring changes, or the deformation. As we add together the weights of different rocks, we can get heavier weights. We'll do this 10 times, and then we'll calculate the deformation. To do this, we subtract the original length of the spring, which is 32 millimeters, from the length after we add the weights. It looks like the deformation of a 3.1-ounce rock is only 22 millimeters.
That's really small.
Let's draw and label the axes. This time, the domain is the mass, and the range is deformation.
The first point is the smallest, 3.12, and the largest is 32.1, 203. That's a big difference.
What do you think? Is it linear this time?
I can't tell. The points are almost in a straight line, but not quite.
It should be linear, so there were definitely a few errors along the way.
I tried my best.
I know. It's okay. It's really hard to get it perfect.
Well, at least I know it's continuous, because we could have weighed any rock as long as it wasn't too big.
Correct. You're getting good at this. Because the data was a little off, we'll try our best to draw a line that connects to the most points possible, or gets closest to the most, at least. I'm going to teach you something new. Let's find the equation for this line.
Huh?
First, we need to find the slope. We can do this by solving the equation m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
And how would we do that?
We can use the coordinates for 2 points on the graph. To be the most accurate, let's use data that we gathered that is also on the line.
So we could use 3.1, 2, and 9.3, 45?
Those would be perfect. Let's plug them into our equation and find the slope.
About 6.9?
Now let's put that into an equation for a line. We also need the y-intercept.
What's that?
It's where the line crosses the y-axis.
It looks like about negative 21.
Now we have our equation. What does it teach you?
The equation of a line shows you the slope or the amount of deformation that occurs per ounce. It also shows you the y-axis, which shows you how much deformation you have when the mass is zero.
Very good. And what are you doing?
Testing the deformation?
I wouldn't do that if I were...
Ow.